हाँ सर. हाँ सर. ओके ओके सर. हाँ सर. ओके सर. हाँ सर. I'll inform my soldiers sir. Okay. Over and out sir. Hello soldiers. Good evening to you all. How's the Josh? Okay. Here at the CSR regiment, we have only one motive today, and that is Stack on Titan. This is the second day of enthusiasm. Today, we are planning a secret attack. Well, I feel we are not well equipped for this attack. So, to help us, we have Lieutenant Ashwin Sundaranjan. He will help you to gain the required skill to carry out in the mission. Well, Lieutenant is very skilled in his way of full stack developer. He is also a trainer and specialist in JavaScript and has an experience in building products from end to end. Mr. Ashwin, I request you to take over the command.
Hello everyone. How are you this fine evening? Can you guys all hear me? Like that's the first thing you need to ask in a video call, right? All right. Just everyone, give me your favorite emoji or a combination of emoji. Let's see. Let's do a comms check. Let's see who has the most crazy combination. Let's go. All right. I guess that's something. Uh, okay. So hi guys, my name is Ashwin, and I've been doing some web development for some time, enough to show you, uh, enough to show you guys around. And today my goal is going to be to just want to show you what I do for fun on the weekends to practice some of my programming skills. They don't exist. Okay. So my aim for today is to help motivate some of you to think about taking up a career in software engineering and more specifically web development. There's a lot of cool stuff you can do in web development, and I want to show you one of the uh, one of the cool things that you can do with web development. Let me quickly share my screen. People give me a thumbs up if you can see my screen. Uh, okay. All right. Let me know if you all can see my screen. Cool. We have some thumbs up there. What an energetic crowd we have today. Okay. So today, what we're going to be building is this particular, if you didn't know, with just your HTML5 default APIs, you can build games such as these. So this is something cool. So it's a very basic game, nothing like your PUBG types. Right? I'm not, I'm not a game developer, guys. So I am a web developer, but this is some of the cool stuff you could do with whatever you learn in web development. Uh, so here we have a very basic game. Basically, you have a bunch of enemies who are trying to shoot you down. You can try to shoot your enemies. You have a health bar. The enemies have a health bar, and there's a score there. Nothing too fancy. It just counts how many things you've got. Let me just. So my previous high score was 15, I think. Let me see if I can best myself. Uh, it's taking long. Come on. There you go. Yeah, cross 15 now. Now I can just end the game. Let me find a bullet. Yep. There you go. So this is what we're going to be building, and this is pretty simple. I'll show you. Like we can build this in under an hour. So if you would like to follow along, I have a basic. I have the basic starter file set up. It's over here. Oops. I'll put that in the chat. If you want to follow along, you can clone this repo. You need to have Node.js installed. So that's one thing. And I'm pretty much going to be talking through how I would build something like this from scratch and sharing my thoughts, sharing the kind of decisions that I make in order to build this stuff. So you can feel free to follow along, but it might be difficult for you to follow along. I might be going
Excuse
fast.
me, sir.
Yep.
Would you please zoom in, because I don't think so they are properly able to say it.
Uh, uh, Zoom in. You mean the game? It's too small.
No, means whatever you are sharing now, it's quite not visible to everyone.
Okay. Uh, let me. I mean, there's nothing on the screen. Like, let me type some text. We'll type the magic programming words.
Soldiers, please drop your comments in the chat box so you can tell the routine end.
Let me know if this is big enough.
Well, sir, the soldiers are saying that not the game, your command screen.
I, Now it's better. Okay, cool. So
Okay,
okay,
Lieutenant.
cool. So in that case, then it's okay. If the game is too small, that's like a feedback. So as you see, when we're building the game, we get to decide everything: how small or big the flights look, and how big the screen is going to be. All of that. So this is what we're going to build, right? So I have this repo clone, and I also have uh, some Node version installed. Doesn't matter what version you have. If you have Node.js, you can follow along. But I would love for you to all just like pay attention to what I'm doing, and probably you can, since it's going to be on YouTube, you can follow along later as well. So feel free to ask questions if something's really confusing. I tend to confuse a lot of people, so that's natural. Uh, so let's get started. So the first thing you want to do after cloning the repo is open your favorite text editor. Mine is Visual Studio Code, and then you want to run npm install, and that's going to install some dependencies, and everything else is set up in this code. And you want to run npm run dev. So this is going to kickstart our uh, development server. You quickly. Yeah, this thing has nothing right now. Get to the screen. So if you're able to see this, then you're all set up. So why is this a development server? If you could see, when I make changes to the code, it's going to auto refresh and save. See immediately there's a difference, and not just on the console. And even if I go to the thing and change the heading, I have to save it actually. Yeah, there you go. So this is our development setup. That's all you need. So let's get started. Okay, so how do you approach this? So first thing you need to know is like the game is powered by something called HTML canvas. So what I'd like to do whenever I'm developing something is go to developer.mozilla.org, and this is like the Bible for web development. It has everything. It has all the uh, API documentation, and you want to search for Canvas API. We go there. So this has a lot of examples. You can learn a lot about how to use Canvas. And Canvas is basically for you to be able to create any kind of graphics on a web page. Uh, so I'm going to have this thing open because I honestly I don't remember all these commands. It's a lot of things to remember. It's always good to have some kind of reference always on the side. And I'm also gonna off screen. I'm also gonna have the source code of this here. So just in case I'm stuck up, I'm just gonna copy my own code to fix it. So software engineering is 90% copying code off the internet, and almost half the time you'll be copying your own code from the past. So that's how we do it. So let's get started. Okay. First thing we want to do is we need some kind of we need a scene. We need a canvas. So that's what I'm going to do. I'm going to create a canvas. Okay? That's all you need to create a canvas. And there's nothing on the screen because this is an empty canvas. But if you inspect the screen, you can see the canvas exists, and it has some default. It has a default width and height. You can see 300 by 150. So that's canvas. Uh, that's a that's width and height. So let's go to our JavaScript file. So JavaScript file is imported into the HTML over here, and you would see something like type module. So that's going to allow us to use import and export statements. So this is basically going to allow us to split our code across several files. That's going to be insanely useful for you to be able to split your files, split your logic along. Okay, so okay, we already know this file is connected and working because we were able to do something on the console. So let me first grab a reference to the canvas. I'm going to say document.query selector, say canvas. Just let me quickly turn off some extensions that are going to get in my way. Quickly reload. It's still working. So now we have a canvas. So the canvas, as you see, has a default width and height of 300 by 150. So let me paint something on the canvas to make sure that it's there. So in order to paint something on the canvas, we need to grab something called a context. Right? So you need to call get context and say 2D. This will give you a context object which has a lot of useful functions. And one of those useful functions is called fill rectangle. This is going to basically give us a solid rectangle. It takes 4 arguments, which is the top x and y coordinates and the width. We saw it's 300 by 150. And if I save this, you're going to see the canvas painted with black. So that's how. So if I, let's say, set the width to 100, it only fills like 200 pixels. So this is like your basic APIs, and pretty much whatever you saw in this game is built with APIs like this. So how do we get from this to that? Let's get started. Okay, cool. Right. The first thing we want to do is, this is a very small canvas. It's not that, it is not good. This is very difficult to play a game in a small canvas. Basically, you'd be here and the enemy would be here. You'd instantly, there'll be an instant game over. So the first thing we want to do is set a width and height to the canvas. Right. So I'm gonna go ahead and just I'm going to create a constant called width. I'm going to set it to 1024 and height to 68. There's nothing special about these numbers. You could have whatever you want. It just gives us a nice 4:3 landscape ratio. So the reason I'm doing this is I'm going to set the width to this and height to the height. Now let's continue to just make sure. And 0, 0, 0. Now we have a very big canvas. Now we can work with it. That's one thing. So another thing you would have noticed is these little airplanes. Obviously, you can draw these airplanes using just rectangles, triangles, and circles. That's if you try to do that with just JavaScript code, it's gonna. I'm not gonna lie, it's gonna take a while. So what I did is I draw, I made those images using Illustrator and exported the image here. And one of the cool things about Canvas is you could draw existing images on the screen. Let me quickly show you how I do that. So first off, we need to import the image. So I'm in index.html, and images, the image is inside the images folder. So the first thing I want to do is import. I'm going to call it flight from images. Okay. So this is going to, if I log this, this is going to give us the URL for the image. Look at this. Yeah, this is going to give the URL for the image. Basically, if I go here and paste it over here, it's going to return the image. We want to create an image object with this URL. So the way you do that is by calling, creating a new image. So this is a browser API. The browser has an image class. You instantiate it and set the images. Oops, that's not what I meant. Image.source to the flight image. And now we could use this image to draw on screen, but there's one problem. Usually images take time to load. They don't like load instantly. Usually there's a network request and it takes time. So the only way you'll know that image is loaded is if you provide a callback function called onload. So there's this callback function which gets fired whenever the browser fetches the image. So inside here, we are safe to use this image. So we will use draw image function. Right? We'll draw like somewhere, let's say X coordinate, let's go 10, 20. And the first argument is actually basically T, it's image. Image, we'll draw it at the top left. And we need to give the width and height of, you need to give the width and height of the image. So image has a width and height. You see over there? Okay, now you got the, I got the image here. But the problem is this is like too huge, right? So how this is so huge, and we could go to this image, like use image editing tools to reduce it, but this is why we have this we have this arguments here. So what we could do is control the width, right? So I could say give it a fixed width, like something like 200 pixels, and I could give a fixed height as well, like 100 pixels. But the problem with this is, you see how the image is distorted. We don't want to have this. We want to, if we scale the image down, we want to scale it like in the actual aspect ratio. So what we could do is a little bit of math, right? So if 200 is the width, how much is that proportional to the actual image's width multiplied by the image height? And now you get 200 pixels wide the flight image, and it has the proper ratio. So this is how we're going to be drawing images. And as you can see, I have 3 different images: one for the player, one for the enemy, and another one for the enemy. Like when you shoot it down, the enemy is going to appear broken. So okay. So let me comment this all out. We're not going to code like this. So what we're going to do is follow full object-oriented programming principles. So for our game, we're going to have one main class called uh, unoriginally named game. Okay. So this is going to allow us to hold all the game relevant information over here, and we'll also make classes for a player, enemy, and all of that. So this allows us to practice all the software engineering principles like abstraction and composition. Uh, okay, and when the game is instantiated, we want to grab some options. For now, uh, we of course need the reference to the actual canvas. So the game needs to know where it has to draw all the items. And we'll keep on adding options as we add features to the game. For now, we need a canvas and we need a reference to the player, right? So let's have the player, grab the player from the option, right? And we need the enemies. We need, and we're going to have a list of enemies. So let's instantiate it to empty right now, and then we will generate enemies after the players entered into the game. Right. Cool. Let's first spawn the player and add some controls so that we can create the player. So for that, we're going to need, we will create a class called flight. So since both the player and the enemy are going to have uh, very similar traits, we're just going to have a single class. Like, okay. So very similar to the game class, we're going to grab some options. We need the position. The position is going to be specified using X and Y coordinates. So this is going to determine at each point in time where the flight is located. So it's going to be position, and there's going to be something called velocity. So since this is a 2D canvas, our velocity will also be in two directions, the X velocity and Y velocity. This is how basically we would be moving stuff around. And what else do we need? That's, yeah, this is, and we need the image, of course. We need to know what image to draw. Okay. And we're gonna have a function called draw. Every object, every class in this game is going to have its own draw method, which, so basically every object would know how to draw itself. So here we'll take the context object. Remember, this context object is how you draw stuff on the canvas. So we will require the context object in the draw function, or we could probably grab that from the constructor as well. So we'll just say, or we might as well grab the reference to the whole canvas, not just the context. And here we can grab the context using this canvas canvas and get context 2D. And one other thing we need is we need to know how big this flight should be. So let's also grab that from the options. And we don't need to get the height because we can get the height by doing the little math I showed you using the images aspect ratio. So we will compute the height using this formula. So it's like this dot width divided by image dot width multiplied by image dot height. Now we know how wide and how tall the image has to be, and when we need to draw this flight, all we need to do is call this draw image function We need to pass the image. The x position is given by this dot position dot x, this dot position y, and we need to give a width and height. Okay, let's see if this works. So let's have a method called start game. This will create a new player. Create a new player. We need to I called it flight. Sorry. So new flight. There you go. We need to import flight from that particular file, and we need to pass in some options. So what do we need? We need to give a position, velocity, uh, image, pass the canvas. Right. That's all we need. So let's start with the position. So where do we want to place the main player? I see. Let's spawn them somewhere in the middle. We know since we're setting the canvas width and height, we could say the x position should be somewhere close to the left side. So we'll say like somewhere around 20 pixels from the left border, and the y position we could say this canvas dot height over 2. So this is going to spawn the player in the middle of the canvas towards the left. And velocity. Initially, when the player loads, the player is not going to be moving anywhere, so we'll set the velocity to 0. And we need to pass the image. And where do we get the image? So, okay, so we could do something like this, right? So we imported the image, we waited for it to load, and then set the image. But since we're only going to have like 3 images in total, even before the game starts, we can like start loading the image. So I'm going to make a helper function. Okay. I'm going to make a helper function that says that will load an image given a URL, right? So this is going to return promise. If you don't know what promises are, I recommend you to check out. MDN. So for now, you can just follow along. I'm just going to copy this. Paste it over here. Uncomment this. Create a new image, and when the image is loaded, we resolve the promise with the image. Okay, this is gonna give us that one function is going to give us an image, and what we'll do here is we're grabbing the player from here. Okay. So I'm going to move this function to the game file. Oops. Okay. When someone, so we will place a button later. When they click it, we'll call the start game. So basically, what do you want to do when the game is started is you want to load the image of the player. You're going to grab the image, import from here. On the load image, like, and since this returns a promise, we can call a function then, and this is going to give us the player image. So we create a player, and we don't need to. We just realize we don't need to grab the player from the constructor. We can initially set it to null, and over here, when you create a player, we can just directly set it to this dot player. And the image, finally, player image. Okay. What else do we need? We need a width and height. We only need to specify the width. Let's go with something like 200 pixels. We'll see how that looks on the screen and then like adjust it from there. I don't think we need anything else. So this will create a player, right? And okay. Okay, now obviously there's nothing on the screen because we're not starting the game. So what we'll do is like create a new instance of a game. We need to provide some options. What options does game need? For now, it only needs a reference to the canvas. So say canvas is canvas. Or there's a shorthand for this. You can just do this and this is it. And then of course we need to start call game.start game. And still there's nothing on the screen because we're not doing anything. We're just creating a player and setting the player up, but we're not really drawing anything on the canvas. So what we'll do is after we load the image, we'll create another function called paint. So this function, this is going to draw the current frame. So the way games work is it's all of an illusion, right? So this canvas is being painted over and over and over again uh, at some each second it gets painted 60 times. So if you didn't know this before, all videos that you see, even the video that you see right now, it's not actually continuous. It's just images rendering on top of each other over and over and over again. So this is how we will simulate motion. So it's sort of like you're watching images in quick succession. It seems as if there's like an active video. So that's exactly. So we're going to have a function which is going to read the current state of the game and whatever this state represents that it's going to draw. So for now, we only have a player to draw. So what we'll do is like whenever paint is called, we will call this dot player dot. We said every object will know how to paint itself to draw. But first, we need to have some kind of background. Have this like blue background. I'm just going to use that. I have a color picker. So that's the color. Oops. So let me just first grab the context. So this.canvas.get context. Maybe the fill style to this color. And we'll fill the entire screen with that color. So it's going to be our background. So this is also going to clear the screen because every time we do fill rectangle, it's always going to paint on top of whatever was painted before. Like if you draw something and call fill rectangle again, it's going to draw over it. I'll demonstrate it. So we'll start from 0, 0, and we will just fill the entire canvas. Height, canvas. Oops. First argument is width. And then we have height. Okay. Oh, still there's nothing there. Because I'm not calling paint over here. So after we load the player, let's call this dot paint to get something on screen. Now we got the background, but still we cannot see our player. So what's happening? Let's go over here. Okay, there's this error. Let me zoom in. It says in flight draw method on line 13, there's an error that says this get context. We're attempting to read get context of something that's undefined. So this.canvas is undefined. That's because we did not pass canvas when we created this flight. So it's an easy fix. Go here, pass the canvas, right? We still don't see the player. Let's check for any errors. There's no error. Okay. So what's going on? So let's see, draw. What I'm going to do is I'm going to expose this game variable to the window so that we're able to do some kind of debug. Let's look at the game object. We have a player, and the position is set to 2384. Oh, the width is undefined. So we're trying to draw. So I wonder why that's happening. So we do pass the width over here. Look at this. Silly. Yeah. Now we should be able to see the player. Here we go. Yeah. Okay. There we have our player loaded, but it seems like a little too big. Like I said, we couldn't know that in advance. So let's tweak it so that there's like, a little smaller, probably 150. That looks better. Okay. Now let's add some controls to move the player up and down. This player, so to do that, we need to listen for keyboard events. So the way we do that is by adding a event listener to uh, the window. So we're going to say window that add event listener, and we're going to listen for the key down event. So this event will fire whenever I press a key on the keyboard, right? And this is going to give us some useful information. And the event dot key, this is going to be uh, saying what key was pressed. So let me just quickly lock this so that you can see what's happening. Okay. I'll open it. You see, I hit F12 to open the window, and immediately it printed F12. So I click on my screen, I press arrow up, it says arrow up, it says arrow down, and then we press any letters, all of this gets pointed. So what we're looking for is whenever the user presses arrow up, we need the plane to go up, and whenever the user presses arrow down, we need uh, the plane to go down. We could do that, or what we could do is here's more. We want to keep going up. So typically in games, as long as you hold the up arrow, things keep moving forward, and so the that's exactly what we're going to do. It's like we're going to have a pair of functions, right? So we're going to listen to when the user presses a key and when he releases a key. Right? Come on, don't be annoying. Okay. So here, I'm going to show you something. So we'll say key down, this one, key up. Okay. So let's see what happens. Right. So I'm going to press down. So it keeps on firing the key down event, and as soon as I release my down button, it says key up. So what we can do here is when someone presses down the key, we'll notice that that key is being pressed, and when they release the key, we'll say that the key was released. So we'll track this in a variable called key pressed. This is going to be an object, and what we're going to do is this.keyPressed, say event.key.to lowercase. We'll set it to true. Whenever someone presses down on something, we'll set it to true. And same thing when they lift their finger, we'll set it to false. Okay. Right. So whenever, okay, now, okay, here's the thing. This function gets called only once, right? So this function gets called once. And if we, let's change the position of the player, we'll need to call this function again in order to draw the position of the player in a different position, right? So typically in all games, you'll have something like an infinite loop, basically, that keeps on checking for new player positions and drawing over and over and again. So this is achieved by using a built-in function called a request animation frame, right? And because of how JavaScript works, you need to do something like this. Right? What this will do is I'm going to log something new, right? Quickly log. And basically, request animation frame is a function that takes another function, and it will call this function once every 16 milliseconds. If you're wondering where that number came from, it basically achieved a 60 FPS. So, and instead of calling paint here, we'll start our game loop here. And if I open the console, you see, look at that. So that's how many times the function is being called. So it would be approximately 60 times per second, right? So here, what we can do is here we'll call paint, so that right now it looks like a static image, but what's actually happening is for every second, 60 times, the whole thing is being wiped out and drawn again. So this is how we would simulate motion. And here, uh, in the paint function, right? So okay, right in the loop, let's listen for if this dot key pressed arrow down. If someone is pressing arrow down, that means we need to move the position, a player's position down. So instead, what we do, we set the velocity of the player, y velocity, to a positive number, let's say like 10. So the coordinate system kind of works the opposite way of an actual graph, where positive numbers means the y-axis kind of runs from negative on the top and positive at the bottom. So it starts from 0 over here, and it just increases until it becomes 700 here. So we'll set the y velocity to 10. But if arrow up is pressed, we'll set the player's velocity to negative 10. Otherwise, if neither of them is pressed, then we should stop moving the player. We'll set the velocity, y velocity of the player to 0. Right? And I'm going to be I'm actually pressing the keys, but nothing happens because in the player draw function, we're not using the velocity. Basically, we're not using the velocity here at all. So what I'd be doing is, I don't want to disturb this function. This function is perfect. It's drawing based on whatever is given. So I'm going to have another function called draw next frame. Basically, this function is going to calculate what the position of the player is for the next frame, and then call the draw function. So we'll just do this dot position dot x is just going to be equal to this dot position dot x plus this dot velocity of x. And there's like a shortcut to this. You can basically do this. And we'll do the same thing for the y. And then we'll just call the draw function. This will move the player up and down. And here, just calling player.draw, we'll say it. So now, when the key is pressed, the velocity is set to 10, and that should move the player. Look at that. There you go. Now we have some controls. But here's a slight problem. If you see, like, I could go off screen, and if I keep holding, it goes way off screen, and like now I'm holding up, it takes a while. We need to stop the player from going off screen. Like when they hit the top edge of the screen, we should no longer let the player go up, and when they hit down, they shouldn't go up. So we'll add another condition here that says if someone presses arrow down, and if the player's position y is already at the bottom, then you should not set the velocity to 10. So you do the opposite, like the player's position should be somewhere above the bottom frame. So, and this player position y, it only gives you the top anchor of y. We need the bottom point, so we can get that with by adding the player's height. So this whole thing, this is the bottom point of the player. This must be lower than the canvas's height. Okay. And the similar thing for up. I'm just going to copy this. So in this case, the player's Y position should be greater than 0. So now I will no longer be able to, so even if I'm holding up, I won't be able to go beyond the border. But this is kind of messy. Let's leave some space here. So we'll say this should be less than canvas height 20. So there's like 20 pixels of breathing space at the bottom. And we'll say this should be greater than 20. So here it stops there. It doesn't go beyond that. Okay, so okay, now we're running out of time. So what I'm going to do is like quickly go through and like now I'm going to listen for so for the Z key to be pressed, and whenever a Z key is pressed, we're going to launch a projectile. So for that, I'm going to create another file, a class. And this is going to require some options. And this means a canvas needs to know where to draw itself. This needs the position, and this needs the velocity. And it's a height and width. Let's also grab a color so that we could give different color projectiles for enemies and the player. So again, we follow the similar pattern. We will draw whatever is needed. So we'll grab the context, canvas, get context, 2D, and this is the projectile is going to be a simple rectangle. So it's going to be position X, Y, the width, height, and of course this needs a color. So we need to set the color to fill style should be equal to this color, right? And we need a draw next frame function. This is going to calculate the new position for the thing, and I'm just gonna, it's just like it's pretty much the same as this one. Just copy and paste this. Okay, so this is how we create a projectile, which is basically a rectangle. And what we'll do here is inside the game, whenever someone presses so unlike the movement up and down, we don't want the user to keep holding a key in order to keep firing. So we'll just like fire only when they press down the key, or rather release the key, right? So here, when the key is up, we'll check if the event key lowercase is C. We could have whatever key you want. Is basically your choice. What we'll do is let's create a list of projectiles that are on the screen. And we'll call it player projectiles because there's going to be enemy projectiles as well. Right. Let's say this dot project player projectiles dot push is going to create a new projectile, and we need to pass a width. Let's start with like a width of 20 and a height of 5. Let's see how it goes. The color, we'll set it to I don't know. We'll set it to orange. And velocity. Okay, now the velocity, when something is fired, it needs to go to the right, which means it needs to have a positive x velocity. We'll set it to 5 initially to see how fast that is. If it's not fast enough, we can increase it. We don't want any kind of y velocity. And we need a position. And since the player is kind of firing the projectile, it should start exactly like somewhere around like here, like on the tip of the player. So the X position is going to be the right end of the player. You can grab that with this dot player dot position at X plus this dot player dot width. So this is going to give us the rightmost point of the player, right? And the Y position is just going to be position Y, and we want to go halfway down, height by 2. Okay. So this is still not going to draw anything on the screen because all we're doing just like pushing an object in the projectiles. So in order to actually draw this stuff on the screen, in our paint function, we also need to paint the projectile. So we will loop over this array. Right? And then we'll call projectile.drawing. So this will, okay, let's see if this works. It doesn't work. Why would it work? Let's see what's happening. Let's first find cannot read properties of undefined get context. So yeah, I did not pass the canvas. See, we've seen this error before. Canvas this one. Okay. There you go. We're able to fire. This is like really slow. Let me try to increase the speed to like, something around 10. Let's see who's. Yeah, that's more like it. So this will be our yeah, this is going to be our step in firing. Cool. So another thing I want to mention is like I think I fired about 50 projectiles. One thing we're not doing is if you look at the projectiles here, look at that. There's like 38 items, and every time, remember this, we're calling this function 60 times a second, and we're looping over all 38 items. Ideally, what we want to do is when the projectiles go off screen, we want to remove them from the array so that we don't continue to waste resources. So we could do that by, we need the index of the thing, right? We can check where the projectile is. If the projectile's position, we only need to worry about the X position because we know on the Y coordinate, it's not moving anywhere. So if the projectile's X position is greater than the canvas's width, then we need to remove the projectile. But here's a problem. Here's one thing you never want to do. Whenever you're looping over an array, you should never ever like manipulate the array. Like if you're looping over an array, it should not remove an item from the array while you're looping over. That's going to cause a lot of bugs. I'm not going to explain why. So ideally, what I would do is I'm going to keep track of the indexes where we need to remove projectile, and what we do is we push this index into the array, and after we're done looping over all the items, we loop over this in this array, and we're going to call this dot player projectiles dot splice. Splice is a function that's used for removing items from an array. We pass the index, and we want to remove one item from there. This time, so I'm going to fire one of these. And now if I check my object, there's nothing here because everything went off screen. Let me just quickly try to, that's going to be difficult to see that. But yeah, there you get the drill. Okay, cool. So now all we need now is to spawn the enemy. We need to spawn the enemy, and the enemy, we're going to do something cool called collision detection. So we're going to spawn the enemies, and the enemies are just going to be a replica of the players. It's just going to be a different image, and they're going to be facing a different side. And if you notice from this game, the enemies are kind of approaching to the left. So that means they're going to have a negative. X velocity. Right. And we also need to constantly keep spawning the enemies. So we can do that, like as soon as someone starts the game, First off, when people start the game, we also need to load the enemy image. So we're going to use something called promise.all. So this is going to take an array of promises, and it's going to call the callback function as after every promise inside is resolved, which is basically if all the images have been loaded. So I'm going to import the enemy. Uh, I name it. Yeah, there you go. Icon confirms. So let's load the enemy image, and this is actually going to be an array as well. So I can destructure it here, and the second thing is going to be enemy image. Now we have the enemy image. So what we're going to do here is like start spawning enemies. We'll spawn enemies at a fixed interval, and we'll also say that at any point in time there's not going to be more than X amount of enemies, and we call this game options. So we let the whoever's like creating this game, we let them pass it as an option. So we'll say enemy spawn interval. I'm going to say 1 second. It's going to keep it in milliseconds, and we'll say max enemies. We'll keep it to 5. If you want to increase the difficulty of the game, you could reduce this number, increase this number. You can play around with it to your own liking. So here, we're going to call something called setInterval. And this is going to take a callback function, which is going to be called every X amount of seconds. That's going to be this. And we'll call function of spawn enemy. Let's not write all the logic over here. So I'm going to create this function. And all this is going to do is going to create new enemies. And enemies are just flight again, but with different options. So I'm going to copy whatever we did for the player and just like adjust it for the enemy. Just leave the width the same thing. Image is going to be, oh, we need the enemy image. We'll pass it as an argument here. And velocity, we said it's going to be a negative velocity. Let's set it to -5 and see how that goes. And position, we don't want to spawn the enemy exactly on top of the player or anywhere to the left. We want to spawn them like on the right side. So the X coordinate is going to be the width of the canvas. And for the Y coordinate, we don't want to exactly spawn them in the middle as well. We just want to randomly spawn them anywhere over here. So that we can do by, so we need any number between like, let's say 20 from the top and like the bottom, the height. So you can do this by set the minimum. This is the minimum amount of, this is the topmost point from where the enemy could spawn. And then we're going to use math.random and multiply it by, and what's it, height. Should be canvas height minus 20 because we want it to be exactly in these bounds. So, and we don't want any decimal numbers, so I'm going to do a floor division, basically truncation. So this is going to spawn the enemies somewhere around here. There might be something wrong with the math. Let's find out. But as you can see, enemies are not spawning. That's because in our paint function, we're not painting the enemies. So let's go ahead and do that. So what we're going to do is like very similar. We're going to loop over the enemies array for each enemy. we're just gonna call enemy.draw next frame. That's it. Oh, that's the wrong image. It's funny. Let me see what happened. Passing the enemy image here. Why am I getting the same image? That's strange. Let's log what's happening here. Also log the okay. Oh, why does it say? It does say plain enemy, but for some reason the load image function is not giving us the right option here. What's going on? Like, let me quickly expose this function. Oh, you know what? I've hard coded this to load this image. I'm passing the URL. I'm not even reading the URL. Now you should see. Yeah, there you go. Cool. Now we have enemies. Problem is I'm shooting at the enemies and nothing's like really happening. So, and I also noticed that some enemies are like spawning like way down below. So you might want to adjust that Y position a little bit. So let me see. Perhaps I like should do some like 40. Oh no. Wow. Okay, that's clearly not working. It's like I hate the math. You know what? So it's going to be minimum of 20. And what's the upper bound? Upper bound is going to be canvas height, which is going to be like something like 700 by 600. Like, so it's going to be 20 and 620. Like, I think that's some big numbers. Yeah, that's like, I think that fixes it. Okay, I'm happy with that. All right, cool. So now what we want to do is like detect collision. So collision detection is like one of the hardest things to do in game programming. And there are like complicated formulas to detect whether like, like when this bullet like hits this part of the plane or this part of the plane. That's like really complex if you want to like find out if a rectangle is like overlapping uh, this complex shape. So people, and that is also like going to be computationally expensive to find out if there's that kind of overlap. So people, what they usually do is like have something called hitboxes. Hitboxes are basically like entire boxes, like you box up the entire flight here, right? And then like you just like then figure out if this small rectangle is kind of intersecting with the large rectangle, and there's like that's like something easy to calculate. So I'm gonna make a static helper function as to check if two objects have collided. So we'll say object 1 and object 2, and we will know if two rectangles are overlapping if two things happen. Let's first much better to explain. Like, so we'll get the top left x position of object 1. It's going to be object at position dot x, and top left y is going to be object position at y, and we get all we need to get the coordinates of all the 4 endpoints for both of the top left, top. Let's do top right. This is going to be the object 1. But you know what? Let's like directly do this. So we need to know if object 1's So if there are two objects, you know what? Iris, you can directly find that out from here, I guess. Like hit detection. Here you go. 3D collision detection now. You know what? Like I said, I'm gonna copy my code from earlier. I'm not gonna lose my mind over this. uh, I'll explain this. There you go. Right. Okay, this looks scary, but what it basically does is this is the top left position, top left X position of an object. We're checking if the top left position, uh, not necessarily top left, just the left part of the object is to the left of the right part of the second object. So basically, I'm checking if uh, this particular part is before that comes before the end of the other part, and it should also. And the second condition is uh, the right part should be after the leftmost part of the other object. And we do the same thing for the top and down bounds. So if all these conditions satisfy, then we know two rectangles are kind of overlapping. So that's what we're going to do. So while we're like looping over the projectiles, we'll do an inner loop and do this check. Basically, we'll loop over the enemies. Right? And for each enemy, we're going to check if the projectile, we're going to check if projectile has collided with the enemy. So here we know now this is a hit. It's a hit. So what we want to do here is, so a bullet has hit the enemy. It can do a couple of things. You could say you could track the health of the enemy and just like remove some part of the health of the enemy. So we're going to do something very simple. If there's a hit, if there's a bullet hits, we'll just like say the enemy's dead, and we'll remove the enemy off the screen, and we also need to remove the projectile off the screen. So the projectile is hit. What we do is like indexes remove. We'll just push this particular index. So, and the enemy also needs to be marked, as being have to be removed. So we need a way to track that. So I'm just going to say enemy.remove equals true. So here you'll reuse the array, or you know what? We'll create another array for enemy indexes. This here you just we need the enemy index. Got that. Push will push the enemy index. And at the end, after looping over the enemies, we'll just since we're even before we loop the enemy, we know that the enemy is no longer there. So what we can do is like we can loop over enemy indexes remove for each index is that enemies dot splice index. Oh. So now there you go. So now the enemy is getting removed. That's cool. So this is basically how you do a game. Like from here on out, it repeats similar concepts. If you look at the, I've done some additional stuff. I have a score indicator that calculates, how much I have a health bar. If you see, I have a health bar for both the player and the enemy. Yeah, that's one thing we have not done here. Let's quickly do that. Oh my god, there's so many enemies. Insane load. Okay, let's have a game over function, like a variable to keep track of whether the game is over or not, so that we can stop animating. So we'll say this.gameOver So set it to false, and to do a basic collision detection here, we'll do something different for this game. Is if the enemy, if the enemy flight kind of collides with a player flight, we'll call that game over. So you kind of have to avoid hitting these guys. So we can do that by using very similar approach. So while we are looping over the enemies, we can check if has collided. If we check if the enemy has collided with the player, then it's game over. And what is game over? We need to. Oh, it's a very simple thing. Just need to stop looping over this function, and this is where the looping actually happens. So we could add a simple function says if the game is not over, then we call the function. Otherwise, oops. Okay. So now let's test. The enemies disappear, and the game gets over. There you go. So you see how they both touched, and instantly the game stopped. So this is a game over function. So yeah, so this is the basics of how you build a game. So we're also like near the end, so we will reserve some time for taking some questions. I would encourage you to clone this repo or whatever. Try this. Try building a basic version, and try building something like this as well. I'll share the link to this particular thing. Here's a couple of things we do here. You notice how as soon as the enemy's health is like down to 0, we don't immediately remove them off the screen. Instead, we're like replacing that with like we're showing that the enemy flight is breaking and they're like going down. So we could do that by oops, it's like game over. We could do that by adding a y velocity to your to the enemy, and that's all you have to do to make the enemy go down. And you add another condition to only remove the enemy when they're like off the screen. Like if their position of x is if their position of x is less than 0, or if their position of y is greater than the width. That's one thing you could do. You could add a score whenever you take the enemy down. Since you know when the enemy is down, you could increment that score and display it here. You could use the, again, refer to the MDN to see how you can draw text over here. And of course, when the game is over, you want to show the summary. And for the enemy projectile, really, there's nothing different here. It's just like I have a timer on a timer, and just like every time, so the enemy would just like randomly fire a projectile, and the projectile is exactly the same class, but the velocity, the x velocity, instead of being positive, it goes from left to right, goes from right to left. So those are the things you could try. So I will definitely. So let's start now. I've been talking a lot. Let's look at the chat. If you have any questions, I'll be happy to answer them. Okay, I can see some question on the chat. It says, what are certain things, certain do's and don'ts according to you? For example, you mentioned don't mess with the arrays in between the loop. Honestly, that's like completely opinionated. Like you know, uh, it's something that you learn over the experience. Yeah, one thing is definitely don't mess up the array when you're looping over it. That could cause some bug. But when I say that, you have to do exactly what I say not to do, so that you can understand. Let's try that quickly. Let's see what happens if we remove stuff. It's gonna be fun. Like instead of doing this, what I'm gonna do is like better. I'll splice it right here. Oh, not this one. Okay, we'll do something like this. It's gonna mess up. That's it. Splice and then index one. So instead of like removing later, so right now it seems like nothing different is happening. But this is exactly the problem. You'll never know what will happen sometimes, like when you remove the array and you're looping over the array, sometimes the wrong index gets spliced. So you want to remove the bullet that went off the screen, but you might end up removing the bullet that has not left the screen yet. Stuff like that. I'm not an expert, so I remember facing some bugs in the past, and that's how I know uh, not to do that. So that's basically how you learn. You keep doing stuff, you break stuff, and then you learn. So do's and don'ts. I just don't restrict yourself to not doing anything. Just go ahead, break all the stuff, learn, uh, learn that way. That's the most fun way to learn. And here's like a few important concepts actually we picked up even in a fun project like this. One thing is your solid object-oriented principles, where we're having game with encapsulation, and you noticed how I'm not like creating any kind of inheritance pattern. So again, if you're looking at inheritance, like usually composition is preferred over inheritance. If you're interested in reading about that, I recommend that you learn about the solid principles. One of the principles is called the Liskov substitution principles. It basically tells you where you need to use inheritance. And most of the times the answer is prefer composition over inheritance. Like don't do something like, I created a flight class, right? Uh, you would notice some people would create like a common flight class, and like they do like class player extends flight or class enemy extends flight. Don't do that. Even if you think that player and enemies have different capabilities, it would naturally happen. You might want to have some additional power ups for the player, like you want to add a shield to the player, but don't want that. In that even that case, what I would recommend doing is, like, let's say if you want a different layer, at, so and all this logic is going to be the same, right? So you want to draw an image, you need to draw next frame. Often temptation is to do something like this, so that all these draw and draw next frame methods are available without you having to write them again. But don't do this, because this is not right. Because when you use inheritance, you're basically saying player is a flight, which may be true, but sometimes most of the times it's not. So instead, what you have to do is you should do something like player has a flight. This is a much better way to, you can now still take advantage of inbuilt functionality. Like if you want to have a draw function, you don't want to implement a draw function, you can simply call this .flight.draw. Still, you get all the code reusability, just like little bit of extra effort. You just need to write one more extra line. So always prefer composition over inheritance. It's extremely rare where inheritance is useful. So that's another thing. Okay. Do you have any more questions? Uh, okay, I have questions. If I had developed any other game than this, no, I am not a game developer at all. I'm a web developer, which means I develop websites. I write JavaScript to, like, your buttons and UI. These games are just something I do for fun, and like I showed you, this gives me a lot of learning about abstraction and composition. So but yeah, I'm really, I want to do a lot of games. So this is what I do on weekends. I'm going to be doing a lot of games in the future. Okay, I see Deepankar in the chat. Hi, Deepankar. Deepankar's working with me.
So, soldiers, any more doubts?
I see. I think I see another question. It says, you mentioned in the starting of the session, web dev is kind of copy paste job. Yeah. So are we able to do so in industries as well? Yeah, man. Pretty much. Like, do you think Facebook doesn't copy paste code? Everyone pastes code. Stack Overflow exists for a reason. There's no shame about copy pasting the code, and that's one of the beautiful things about open source. The only thing you need to be mindful of copy pasting is just be mindful of potential licensing issues. You need to ensure that the code you're pasting is under some kind of open source license. That's the only thing, which it is for web development. It's like 99% of the web development projects, libraries are like open source.
Any more doubts, soldiers? thank you, Lieutenant, for your time today and for teaching us more about the development, and even the soldiers for attending. Be ready for an all stack among yourself because you'll be facing off in the Stack on Titan competition starting from 9 till 13. And please give your valuable feedback. The feedback link is in the chat box.
I'll share the complete code for whatever this hosted game is like. I'll share the link and the code with the team. Please do share it with everyone. Pratik, thank you for this.
Okay, thank you, sir.